Welcome back. In this little video, we're going to talk about why triangles and why congruence for triangles, right? Why are we examining triangle congruence? Why not just congruence in general? Well, triangles are really powerful in geometry because everything in geometry is triangles, okay? Every shape, even a weird thunderbolty shape like this one, is actually just a bunch of triangles stapled together. You might remember this from when we did tessellations, right? That we saw that squares, that's just triangles. Hexagons, that's just triangles. It turns out every polygon is just triangles in the end. Even circles are triangles. You could construct a triangle using a compass, or you construct a circle using a compass, and a compass is a triangle, right? So all circles are also made using triangles. And lastly, even in 3D, right, we can approximate every object with triangles. The more triangles, the better. Even three-dimensional objects, something organic and pretty round, like a bunny, right? Now, video games will use polygons to measure the resolution, how detailed and realistic an image is. But those polygons, they're all triangles. It's all triangles. They might as well just measure them in triangles, right? That's the power of triangles. Everything can be approximated, constructed, or broken down into triangles. So if we can understand triangles, we can understand everything. And that's why a big part of geometry is trigonometry. Trigonometry, the study of triangles, also is the study of circles, actually. And that is because of the intimate connections between triangles, polygons, and circles. Now, congruence is important to us because, again, in math, we like to show what things equal, right? But in geometry, we don't show equality as often. We show congruence, right? We want to show that two things are congruent to each other. For example, if I want to show that this is, say, a square or a diamond or a trapezoid, I want to show it's congruent to a square or diamond or trapezoid, right? I don't want to say it's equal to, I want to say it's congruent to. So by understanding congruence and triangles, we're going to understand a very important concept for everything. So let's break down. Okay, what is the definition of a congruent triangle? Well, in the last video, we talked about what congruence was in general, which was same size, same shape, right? And previously, we had talked about what was size measured with? Well, that's side lengths, right? And what was shape measured with? That was angles. So say, for example, I'm going to give you two triangles, right? Two triangles real quick, right? And I'm going to give you another triangle right here. I'll make it a little tougher. Are those triangles congruent, right? Let's label some things. I'll label the points. Are these congruent triangles, the triangles DEF and ABC? Let's examine it, right? What I need to know is, do they have the same sides and the same angles, right? So I need to match up the sides to the angles. Does every side have a matching side on the other one? Well, it doesn't look like it immediately, right? Because they're facing different directions and all that. But I could realize, oh, what if it was just, falling over on its side or rotated or something, right? So again, if I can rotate it and flip it back upwards and it would look the same, right? When I do that, that would be good. Well, I don't have any measurements or anything, so we could add those. I do see I have a right angle here, right? And then I'm going to give you some measurements. I'm going to say, this is 4 and this is 4. This is 3 and this is 3. And this is 5 and this is 5, right? Okay, does it look like it's congruent now? Yeah, right? It seems like there's matching side lengths and matching angles, right? Well, I probably should give you some more angles too, huh? So I'm just going to, give you, I'll just use notation marks here, right? These two are congruent. These two are congruent angles. Are those congruent triangles now? Well, they got the same angles, right? They got the same side lengths, so it works. But let's break down exactly what's going on here, right? I need to match up every side length to another side length. So what are my matches? Well, I can see that AC, right? The side AC seems to be congruent to the side EF. How do I know they're congruent? Because their side lengths are equal, right? Equal side lengths means congruent sides. Okay, so next up, I've got AB is congruent to DF. And lastly, I've got BC is congruent to, looks like DE. Notice I'm using my notation. Okay, so I've matched up all these, right? Now I need to do the same thing for angles, right? I need to match up my angles. So I can see that C seems to be congruent. Well, it's noted, right, with the double line notation, congruent to E. And then B is congruent to D. And that leaves A being congruent to F. So you'll notice what I've really done, right? I've broken down these triangles into 3 side lengths and into 3 angles, right? So there's 6 total things I need to jumble up and match up. 3 sides, 3 sides, 3 angles, 3 angles. So to prove that 2 triangles are congruent, I need to check, do all the side lengths match up? Do all the angles match up? So I have 6 total pairs to find. 3 pairs of side lengths and 3 pairs of angles. And I can go the other way. If I had just straight up told you that these triangles were congruent, right, then you would have known that all of these pairs had to exist, right? Now, the way we write this congruence is going to be a way to be able to tell you all of these pairs without needing to tell you those pairs, right? Because mathematicians, we're not lazy, we're efficient. So if I wanted to say that the triangle ABC is congruent to the other triangle, I'm going to put these points in a very specific order, right? I'm going to put them in the order of F, D, E. Why that order? What is special about the order I did there? So maybe pause the video and think about that. Why did I put them in the order of FDE, not DEF? Okay, hopefully you came back from pausing the video and you try to figure out why is it in the order of FDE? And you'll notice I put them in the order that their points match up, their angles match up, right? A matched with F, B matched with D, and C matched with E. So by putting them in this order, I'm telling you right away all the congruent angles these triangles have. So just by giving you this congruency statement, you know all the congruent angles they have. And check this out, I'm also giving you all the congruent sides. FD, right, that matches with AB, as we saw before. And I can see here that BC matches with DE, right? So by looking at the order that the double pairings are listed, right, these 2 letters next to each other, I can also see the congruent sides. Even AC matches with FE, right? Handy, convenient. Okay, this two-way relationship, we use special words in math when we need to write that out. So allow me to show you in English, right, and an English sentence how I would write that out. I'm going to say this. 2 triangles, actually let me type this out just so it's even easier to read. I know some folks always struggle with reading my handwriting and I do not blame you. 2 triangles are congruent if and only if, those are the magic words, if and only if all their corresponding sides are congruent and all their corresponding angles are congruent. That is the definition, right? And notice again, these magic words, if and only if. Those words are very powerful because if it was not just, if it was just if, right? That would mean 2 triangles are congruent if all the corresponding sides are congruent and all their corresponding angles are congruent. But there's other ways they could be congruent in that case, right? Maybe they don't need all of their corresponding sides to be congruent. That would what one if would imply. By saying only if, there's no other way for them to be congruent. This is congruence. This is the only way for 2 triangles to be congruent, right? You can't skip any of this. You need all 3 pairs of sides to match, and you need all 3 pairs of angles to match. So you need to find 6 total matching pairs, right? That is the only way to show congruence. And that's what this if and only if means. There's no other way to do it. This is the way. Okay, well, there's some shortcuts we can take because 6 pairs is a lot of work, right? That's a lot of stuff. Mathematicians, we're efficient, right? We don't want to have to find 6 pairs. So we're going to investigate in future videos the shortcuts needed to be able to find these 6 pairs. Because sometimes you only need a couple of the pairs in order to figure out the rest of the pairs using angle relationships and things like that. Okay? So I look forward to seeing you in our future videos next week, and I hope this video helps you out with understanding the definition how we got there, why if and only if is so important, and seeing why we need 6 pairs in particular to be able to get this. Have a great day.